With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
A circuit has a section A, B, C. If the potential at point A, B, and C are V1, V2, and V3 respectively, calculate the potential at O. Okay. So they have given you one circuit in this question where they are marking you the different currents with their direction. See, I1, I2 and I3 are three different directions which they have marked, and correspondingly they have marked their potentials also as V1, V2 and V3. So with the junction point O, that is at the node point O, you are supposed to find the potential. So let us call the junction point potential as V0 here. Okay. So V0 is the potential at O. Let us label like that. Okay. Now, we shall first apply the current law, Kirchhoff's current law. That is the first rule. And using that Kirchhoff's current rule, applying KCL. That is the Kirchhoff's current law or the junction rule. So the sum of the currents entering the junction is equal to the sum of the currents leaving the junction, or this total algebraic sum of currents will be equal to 0. See here, all the currents are leaving the junction, not entering the junction. So you will write that as minus I1 minus I2 minus I3 is equal to 0 because all are leaving the junction, right? So you can write this as I1 plus I2 plus I3 is equal to 0. So let us call this as equation 1. Now we have potentials V0, V1, V2 and V3. Now let us write the difference between the potentials at each branch, so right? Between OB, between OA and between OC. So how will be the potential? The potential will be the potential difference between them, right? V0 minus V1. V0 minus V2. So like that, every potential at the junction we will write it. So that gives you, like, if I am writing for the first one along OA, if I am writing, then it will be V0 minus V1 will be equal to the resistance. How much will be the resistance? Current is I1, resistance is R1. Similarly, along OB, it will be V0 minus V2, which is equal to I2, and its resistance is R2. Similarly, along OC, V0 minus V3 is equal to I3 R3. Now from each one of the equations, let us write the corresponding current values. Like, see, from V0 minus V1, if you are writing this equation for current, then I1 will be equal to how much? It is V0 minus V1 divided by R1. Similarly, for this, I2 will be equal to V0 minus V2 divided by R2. Same way, if you are writing it for I3, I3 will be equal to V0 minus V3 divided by R3. So these are the three different currents you have. And now you have one more equation for current here, right? I1 plus I2 plus I3. So substituting all these values of current in this equation, what you will get this equation? So this equation, putting all these in one. Putting in 1. So when you substitute all those in 1, what will be the equation? I1 is V0 minus V1 divided by R1 plus V0 minus V2 divided by R2 plus plus V0 minus V3 divided by R3 is equal to 0. Now in this we will take V0 common for all the terms, so that V0 all the terms we will write it to one side and other terms we will write it to the other side. So you will get it as V0 into 1 by R1 plus 1 by R2 plus 1 by R3 minus all the other terms which is remaining, that we shall write it. So that will be like V1 by R1 plus V2 by R2 plus V3 by R3, which is equal to 0. So still, if you are further simplifying this and writing it for V0, you will get the value as V0 is equal to V1 by R1 plus V2 by R2 plus V3 by R3 divided by 1 by R1 plus 1 by R2 plus 1 by R3. Now see to the choices what you have for V0. See, V0 is V1 plus V2 plus V3 divided by R1 plus R2 plus R3 divided by 1 plus R1 plus R2 power minus 1, which means it is in the denominator. See what we have got? It is very similar to the what equation we have got. So according to the answer we have got, option B is the right answer.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.